in a kind of way the following video in the oscilloscope tube circuit. Now it's here, I've built it in. We see here a beautiful horizontal line, etc, etc. There is some say perspex glass to safeguard the tube. I've used the say most simple way to make the high voltage work. Anyway, it was in an earlier video and I surely will show the schematic about that high voltage generator. There were two earlier circuits, by the way, of making such a high voltage generator with a high voltage old school television tube, a line transformer tube. I made two circuits, both worked. The second circuit was somewhat better compared to the first circuit, but anyway, both circuits, and when you go back to the earlier videos you can see it worked properly, and there always must be a safeguard resistor of 30 ohms at 10 watt to the high voltage generator. And then I mean the high voltage generator that was made with a standard, more or less standard, classical, old school high voltage coil. I will take it up now. It will take some time perhaps. Have to search. Well, it's here. It's here. This is that high voltage generator made with three transistors. Schematics are in the earlier videos. This is a typical high voltage coil to drive a cathode ray tube, but the more easy solution is here to drive that out of a few standard 230 volts or 110 volts transformers on 50 Hz or 60 Hz, and then use the secondaries of these transformers. And there's more told in the earlier video. So we have here in a certain way approximately say 110 volts, 130 volts AC. It's doubled with the voltage doubler, etc, etc. So this was a good experiment, by the way, here. A good experiment to make such a high voltage with a old school television transformer on 16 kilohertz, but this worked better, was more stable, etc, etc. So choose what you want. There are two high voltage generators in my earlier videos. And what I want to talk now is about say the filament voltage and filament current. This tube needs 6.3 volts at 300 milliampere as the filament current. You can say make that voltage in many ways. Often you see that such a filament voltage is made purely out of an AC source. Say a transformer that can deliver 6.3 volts at 300 milliampere or 500 milliampere, and the wires are the AC wires are directly connected to the filament. That has also to do with, say, the way that such a tube is made. There are directly heated cathodes and indirectly heated cathodes, and this tube has a indirectly heated cathode. That's important, of course, to know. Well, here you see what I've made, and please don't take this circuit too serious in a certain way, because I had this transformer here of approximately 12 volts. I wanted to use it, say it's much better to use, for instance, or not much better, but it's another option, cheaper option, easier option, to use here a 6.3 volt transformer that heats up the, say, the filament of the tube directly. Here is the filaments, here are the filaments of the tube. Cathode is on minus, anode is on positive, anode is on ground. Anyway, I will talk more about that, why that anode is on ground and positive. Has everything to do with the high voltage generator anyway. So, this is a more or less overdone circuit, but perhaps it's interesting. It shows the filament voltage to the cathode ray tube. At this moment, built-in property here, you can see it here. And you can also see here that the filament voltage is okay, otherwise we don't have such a bright line here on the horizontal plate. So there's enough emission of electrons flowing from the cathode to the anode. And the anode is here on ground, 0, minus. And I will tell more about, say, how important it is that the anode is on ground 0, minus. Has everything to do with a charge that you can send to the horizontal and the vertical plates. Anyway, so this is the circuit. I hope that it is visible from this distance. It's in fact very, very simple. It's a, say, standard Miller circuit, and these two resistors are responsible for the output voltage. You can also use here a Zener. It's a classical, say, standard Zener series regulator, but I did not use here a Zener. I only have used here a voltage divider, and that means that, say, when you divide the voltage here, you have here 12 volts, and the two resistors are 1000 ohms. You have here approximately 6 volts, and that is the idea. And I did some experiments. At first I used a 1K resistor here, bridged it with another 1K resistor. So finally this worked out, so that we had here 6 volt 300 milliampere at the output. And say the transistor here, the transistor circuit, that's all that it does is dissipate. In fact, it acts as a kind of series resistor to the filament. That's the most important thing. Gets a little bit warm, needs a heatsink here. I've used a 2N3055 on this heatsink. So, well, when you want to make it more simple, use, for instance, resistors. Simple power resistors, but this transistor acts now as a kind of power resistor to limit the current and the voltage to the filaments of the tube. That's here. And you can see here it's 6.3 volts that is now present to the filament of the tube. And the good thing is, perhaps that's interesting to show, that when you change this resistor here, you can fine tune the output current and the output voltage. So now you can see here two resistors of 1K bridged, but when I add to them this other resistor of 2200 ohms, you will surely see that the voltage goes up. Say, now it's 6.8, that's far too high, because the tube needs 6.3 volt as a filament voltage. But this resistor, for instance here, this resistor here, that is, say, here, with changing, doing some experiments, always stay on the safe side. So take the the resistors higher than you expect, etc. With changing the value of this resistor here in the order of 500 ohms up to approximately 1000 ohms, you can set the filament voltage and of course also the filament current. And the good thing of this circuit is that it is a kind of Miller, it is a Miller circuit. So we have here also to do, say, with the effect that the filament here sees a very stable, smoothed out voltage. Though again I have to say, when you look at circuits out of the 1950s and 1960s, tube circuits, etc., this was absolutely not done in those days. 6.3 volts on the filament was directly connected to the AC source. Anyway, it's only my idea. Thanks for watching. This is, by the way, the circuit as it is. Now I'm still doing experiments to get the brightness grid under control. Used here a few potentiometers here and there, etc. Well, perhaps I'm going to make a new video about that, but on the other hand, perhaps this whole video series gets too long and I will only show the definite schematic within a few weeks. Thanks for watching. Pen over somewhat. And here is that transistor, the 2N3055, that in fact has the job of acting as a power resistor with a variable voltage out, variable current out, of course, also regarding Ohm's law. that was more or less all to tell. Thanks for watching.